So Dr. Kartini, do you ready? So okay, sekejap. So now I would like to read a short CV from Dr. Kartini Jaafar. Okay. So Dr. Kartini graduated from UM. Okay. She start serving for UiTM in 2000, in year 2000. Okay. From lecturer DT3 until now. Okay. So she is expert in conductive material, especially grafted polymer material. Okay. Okay. So without further ado, please welcome Dr. Kartini to present a study on structure and electrical insight on grafted biopolymer conductivity, film based on Chitosan-g-pmma incorporated with cation salt. Okay, Dr. Kartini, the floor is yours. Okay, good luck.
Bismillahirrahmanirrahim. Assalamualaikum and good morning. Thank you very much, Dr. Rose, for inviting me and introducing me to the audience. Today I just to share a few knowledge that I get from my PhD, and then the research continue by my students. Okay. Okay, the title of my presentation today is Structure and Electrical Insight on Grafted Biopolymer Conducting Film based on Chitosan-g-pmma incorporated with a cation salt. Okay. This is a little bit background of my study. So actually, what is polymer electrolyte is that polymer electrolyte actually introduced by a researcher before to replace and overcome a few problem in liquid electrolyte as the problem come from the leaking of the liquid, and then introduce the short circuit and then rough to the electrode of the energy device. Okay, so we introduce polymer electrolyte to replace and overcome the problem. So a polymer electrolyte is a little bit like solid polymer electrolyte. Okay? So polymer electrolyte is a ion conducting membrane with a moderate high ionic conductivity. So to have a good polymer electrolyte, the conductivity of the electrolyte must be more than power of -4 Siemens per centimeter at a room temperature. Yes, usually polymer done is PEO, PVC, and then some researchers choose the natural polymer, like chitosan, cellulose, and etc. And then we can fabricate, use in any solid state electrochemical device. Okay, so actually polymer electrolyte content of polymer host itself plus any inorganic salt, okay? And then that's how we produce polymer electrolyte. So polymer electrolyte itself must be very high conductivity, and when we want to fabricate to the electrochemical device, must be high conductivity, good mechanical strength, good thermal, chemical, and electrochemical stabilities, and then the most important is must be compatibility with the electrode material. So how we can get the polymer electrode, especially with the high ion conductivity, it depends to the polymer host actually, okay? And then juga it's depend to the salt that we use lah, okay? Because salt we are giving the ion within the polymer to have the potential difference. So so polymer host itself must be good enough amorphous characteristic, because to lack the ion moving or transport within the polymer, and then low glass temperature and a high dielectric constant. With the high dielectric constant, make it easy to store the ion within them, and then it's had to associate the salt to have the to become ion. Okay, so therefore the scientists before do some modified of the polymer host. How it's modified, such as blending, blending within a few kind of polymer. We do the co-polymerization, we put some precization and composite to enhance the ionic conductivity of the polymer electrolyte. Yeah. So why, in my word, why I used Chitosan? Okay. So in my work in PhD, I use a biopolymer or natural polymer Chitosan. The advantage of Chitosan is that it's because it's a second most abundant natural organic resource net to the cellulose. Actually, this come from the campaign of green technology, save your world. Okay, and then we try to replace the synthetic polymer to the natural polymer. So since it's a natural polymer, it's where Chitosan is biocompatibility, biodegradability, easy to dispose, and non-toxic, and of course is because of the abundance is very cheap. Okay, and then scientists before also showed that Chitosan have a hydroxy and amine functioning group that can composition with the salt. Okay, and then is quite suitable for the preparation of solid polymer electrolyte. But the few disadvantage of the Chitosan is, because it's this is a semi-crystalline polymer, so the conductivity is very low. Some researchers show that within the power of -7 Siemens per centimeter. Okay? And then the nature of Chitosan is willing to absorb moisture. Okay? When it absorbs the moisture, make the structure is mechanical strength of the structure is low, and then when involve the water, is not very suitable for a lithium-based electrolyte cell. So I try to improve the toughness of Chitosan and the water resistance of the Chitosan, and try to enhance the conductivity of the Chitosan by grafting a little bit synthetic polymer onto the Chitosan chain. Okay. So what is grafted actually? Yeah. So grafted is a method where monomers are covalently bonded onto the polymer chain. Okay. So for the example, A is the main polymer chain. For my case, A is the Chitosan chain, and B is the side chain graft monomers. So for my study, we use MME. yeah, metatralite. Okay, and then how we graph, actually there many method how to graph within the two polymer. Biasa we use chemical, radiation, photochemical plasma induced technique, and we use enzyme. Okay, but almost of them involve a new chemical, okay, inside within the polymer. So unless radiation, yeah, radiation no needs any chemical or any theater involved. Okay, within the polymer, you just radiate the polymer, and then the grafted will occur. So then my work, I grafted Chitosan with the PMMA via gamma radiation. Yeah, this is a little bit simplest of the preparation or method of my work. I just first just blank within Chitosan and actually monomer, monomer MMA, not PMMA yet before we graph. Okay, and then you just blank, and then we send the sample to the mean touch sinar gamma at nuclear measure, Bangi, to radiate with the gamma rays. Okay? And then before we start to make it as an electrolyte, we categorize it first to confirm that the grafted is occurs within Chitosan and MMA by SRD and FTIR. Okay? And after we confirm that the grafted is occur, we prepare the electrolyte. Okay. First, I try use a lithium triflate. Okay. But during my study, I use a lithium, and then I add up some plasticizer, which is ethylene carbonate. So actually, function of plasticizer ni it makes our film more soft, and then is avoid our film to crack. Okay, and then of course EC also help the film enhance the conductivity. Yeah, because of the EC will produce the mobility of ion will enhance within the polymer when EC involved in the matrix. Okay, and then actually there is a little big problem with the lithium. We know that lithium is very high considerability of salt within the polymer, very active salt or ion, and can produce very high conductivity. But the problem of lithium itself is very active, and then is cannot be exposed to the air, and make it destroy. And then anything preparation of the electrolyte within the lithium, when we use lithium, must be do in a glove box. Okay, start from the electrolyte preparation itself, and then when we want to fabricate with the others, we fabricate to the device like battery or supercapacitor, and then when we to test the LSV and anything, we must do in a glove box. Okay, and then the glove box also must be good condition. Sometimes kalau not provide good maintenance, it can make our lithium salt and any lithium film inside the global will destroy. Okay, that's why I try with my student with the others salt, which is magnesium. Okay. And then from that, after we blend all together, and then we make it dry to make a film, and then we test with the IR and EIS and LSV. Okay, this is a spectrum of SRD for a grafted polymer, where we comparison between this is a spectrum of pure Chitosan, and this is a spectrum of pure PMMA, and then after we grafted, we have the spectrum where the both of peak of Chitosan and PMMA appear in the spectrum. Okay, so from that we just conclude that the successfully of PMMA grafted onto the Chitosan backbone. Okay, and then we can see also the peak of Chitosan slightly reduced, and then we assume that the crystallinity of the Chitosan will a little bit reduce. Okay. And then from IR also, we can see the spectrum of grafted polymer. There is both spectra of group PMMA and Chitosan appear within the spectrum. Okay, this is a spectrum of characteristic spectrum of PMMA. Okay, this is the spectrum of pristine or original PMMA. Then this original Chitosan, and then when we graph it together, you can see that the appearance of both peak within the grafted polymer. Okay, and then you can see the amine group of Chitosan is little bit reduced, and means that the grafted must be occur within amine group of Chitosan. Yeah. From this result, we also can conclude that grafted is successfully. Okay, and then when we blend the grafted polymer, the lithium, you can see that the spectrum of grafted and blend the spectrum of blended polymer and lithium, we can see there is a peak of lithium itself within the spectrum, and then we can say that there is a complexization in between the polymer and the grafted polymer and the salt itself. Also same with the magnesium, we can also see in the blend Chitosan blend polymer, grafted polymer with the magnesium. I can see also the existing of peak of magnesium triflate within the spectrum of the blended. So we assume also the complexation between grafted polymer and the salt if occurs. Okay. And then we test the sample with EIS. Just show here the value of conductivity that we get. Okay, so the value of the conductivity maximum, we get anti-power of -4. Okay, for it shows that grafted polymer will produce or will enhance the conductivity of the chitosan, and then also we helpful of plasticizer. Actually, kalau without plasticizer, the lithium system very have higher conductivity to the magnesium system. But when we use the plasticizer, okay, we can show that actually the magnesium system also can enhance the conductivity within power of -4 Siemens per centimeter. And then when we study about window stability, what is LSV actually? LSV study to determine the maximum operational potential of the polymer electrolyte. So we can see that the potential stability voltage for the both is lithium system and magnesium system until to 3 above 3.2 and 3.4 volt. So this is good enough potential stability when we do fabricate with any electrochemical device. Yeah. So conclusion from my study, PMMA was successfully grafted onto the chitosan backbone while gamma radiation method. Yeah. Both sample of grafted polymer electrolyte, which is lithium and magnesium system, show a good value of conductivity, maximum up to power of -4 Siemens per centimeter. And then also both of system show very good electrochemical steady of potential different up to 3.2 volt and 3.4 volt accordingly. So very appropriate to be used as a separator of electrode in the fabrication of energy device. Actually, for lithium system, I already tried to fabricate with supercapacitor. It showed that the compatible of polymer with the electrode, and we just use the carbon electrode. But to have a very good cyclability and very good capacitance of supercapacitor, we must adjust the electrode also. Yeah. That's all. Just to share, okay, that's all for my presentation for my study. I just to share here. What is Mintexina Gamma provide for us at Nuclear Malaysia agencies. So they have two type or two side of service. First, for research lobe, we can send our sample to there to radiate. To radiate to radiate our sample. This is the opening. How our sample will go through to the house of gamma sources. Okay, this is house of gamma sources. Our sample will go through the gamma houses. Okay, and then it also provide for industry actually. Kalau for research, I think not tak ada charge rasanya. Dia akan bagi biasanya it's a free service for the students. And then for it also have the industry side. So this one, they use a very big gantry or container to make radiate in the uh, gamma housing, okay, ataupun cobalt 60 housing. Okay, this is roughly the housing of gamma sources. Okay. So actually, for industry biasanya for destroy microorganism, okay, for sterilize lah. Okay. I think that's all for my presentation. Thank you very much.
Alhamdulillah. Thank you very much to Dr. Kartini also. So it's good presentation and good knowledge for especially for new researcher or new lecturer, and also for student which involved in grafting polymer. Okay, so now we open for the Q&A session. Any question, you can unmute your mic and start question. Any question from audience? Okay. No question. Alamak.
Assalamualaikum.
Waalaikumsalam.
Okay, Dr. Kartini, I want to ask about, you use radiation, right? And actually what the SOP and difficult tak untuk kita bila kita involve research kita dengan radiation?
Again? Tak clear tadi.
Hello?
Hello, okay.
Okay, Dr. Kartini, your research involve the radiation. How dia punya challenge lah bila kita involve radiation ni dari segi SOP penggunaan your radiation dalam your research.
Actually, we not involved directly to the radiation. You just send the sample to the Mintesh Sinagama, and then a few days after that, they all call to collect the sample. We not involve any radiation inside that.
How about the charges?
The charge, I think, for researcher with the research lobe, there no charge for us.
Oh, okay, very good.
And then, but for the industry, there is a charge lah.
Okay, thank you.
Good news for us. Okay, thank you. Okay, regarding for your presentation, you have tested two type of salt. Okay, from the conductivity value, which salt, which polymer combination of the salt shows the best?
Actually, cannot be cannot be the speciality of itself lah. It's a very active salt ion, very produce a good conductivity itself. Without EC content is already achieved anti-negative 5 or 4. Okay, and then EC just only to make our system or our film quite soft, right, to avoid crack. Yeah, and then but for MG itself, the alone the quantity is very low lah, but it must be helped by plasticizer to enhance the movement of salt within the metric.
Okay, thank you, Dr. Kartini. So there is one question in our chat board, okay, from Muhammad, maybe Dr. or Encik, I don't know. Muhammad Nazi Saad, okay. Is the material safe for biological application, for example, in the medical application? Maybe because it involved with radiation. Is it safe for biological application?
I'm not sure, but I not try. But in many general medication pun, I think that there are lots of use of chitosan, and then some of them also grafted to uh, to enhance the characteristic of a chitosan. But when we use the synthetic polymer, I'm not sure it's suitable or not in the medical. Okay, maybe you can blend with the others natural polymer to overcome any problem with the chitosan.
Maybe the gamma ray is not left in the polymer. Is that it?
No.
The gamma is we use the energy, isn't it?
Yes.
To grafting. Okay. So one question from Abdul Mana. What is the form of Chitosan and MMA before gamma irradiation process?
Actually, we blend together. We must dissolve first lah. The raw material of chitosan is powder, yeah, and then I must dissolve first, and then blend with the MMA, and then why I radiate to the sinar gamma is in medium of a liquid lah. Okay, and then after that I just dry it again, yeah, to make powder again, yeah, or raw material of grafted chitosan. Before
what type of
we
solvent? What type of solvent?
solvent chitosan, we just use the special chitosan solvent, which is acetic acid.
And then from Abdul Mana also, beside gamma radiation, is there any easier grafting method?
I'm not sure, but maybe kalau chemistry punya side, our lecturer chemistry can introduce any theater chemical to process of, because it's involve ionization process to make a bonding in between chitosan and MMA. So maybe we can use a chemical also to produce it. My students before tried to just use microwave, yeah, but the punya grafted is not very successfully lah, because the microwave punya energy is very low to create the ionization.
Okay. Last question. After this, we go to the next presenter from Dr. Aziz. Okay. Salam, Dr. Kartini. Grafting method via radiation scission. Which chemical bond are targeting in PMMA or chitosan bond? Bond undergo scission?
The bond, actually there is ionization bond in between electron atom of chitosan and MMA itself. So that's a very hard bond, not just blank within them. Kalau kita blank je, there is no bond in between within the two polymer. Just a van der Waals bonding.
Okay. Photopolymer pada PMMA ke chitosan? Which one is the mother polymer?
Mother polymer is chitosan itself.
Chitosan, so photo scission on the chitosan lah, kan? So thank you for everyone, and also thank you Dr. Kartini for the interesting presentation. Okay. Then now we go for the next presenter, which is PS Dr. Nuru Isrini, Ikhsan, and Dr. Nuru Izrini is graduated from Universiti Putra Malaysia for a bachelor and master, and for the PhD, she done her PhD from Universiti Malaya. Okay. She started working with UiTM from August 2016. Okay. From August 2008, okay, as a RO from Science and Technology Research Institute for Defense, right? And after that, being lecturer from July 2009. Okay. Her special research, okay, is in chemically modified graphene, graphene-based nanocomposite, metal nanoparticles, electrochemical sensor, and also optical sensor. So, maybe Dr. Okay, dah ready, Dr. Nuru Isrini? Okay, so without further ado, please welcome Dr. Nuru Isrini. Okay, Nuru Isrini, the floor is yours.
Okay, let me share first my slide here.
Okay, sila.
Okay, can see my slide?
Yes, can. Okay, boleh.
Alright. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all the audience. Thank you, Associate Professor Dr. Rosna Zakaria, for the nice introductions about me. And first of all, I would like to thank Renew as an organizer for giving me the opportunity to share my research work in weekly sharing sessions with 5-star UiTM RG and RIG webinar sessions for today. So again, my name is Nurul Izrini binti Ikhsan, and I'm from Electroactive Materials RIG, Faculty of Applied Sciences, UiTM Shah Alam. And today,
Dr. Nuru, can you put the slide on the presentation mode?
Oh, sorry, yes, okay. All right, yes, okay.
Thank you.
Okay, so for today, I will share with you a part of my research work, actually a previous research work with a title, Graphene Oxide-Based Metal Nanohybrid, a diversity of eco-friendly approaches, and also the characterizations technique. So this is the outline of my presentations. I just start with a brief introductions and then go for the metal nanoparticles, followed by the role of reducing and stabilizing agents. And then we go for the eco-friendly approaches. And I will explain about a graphene oxide-based metal nanohybrid. And then I will share with you about our research novelty and also our previous research findings. Yeah. So as we all know, nanoparticles is a small particles that ranges between 1 to 100 nanometers in size. And for metal nanoparticles is a sub-micron scales entities made of pure metals, for example, gold, platinum, silver, titanium, zinc, and etc. And nanoparticles are usually obtained through two different approaches. One is a top-down approach and second one is a bottom-up approach. So for the top-down approach, a bulk material is break into smaller pieces using mechanical, chemical, or other form of energy. And some of the methods is related to the chemical etching, laser ablation, mechanical milling, sputtering, and also the electro explosions. And then for the bottom-up approach, the material is synthesized from atomic or molecular species via chemical reactions, allowing precursor particles to grow in size. And then this bottom-up methods is the approach that is mostly used by scientists in the synthesis of nanoparticles and by reductions of metals of a metal salt with a strong reducer. And then one of the the techniques that related to the bottom-up approach is related to the chemical vapor deposition, sol-gel process, laser pyrolysis, and also the atomic molecular condensations. And also under the bottom-up approach, we also have a green synthesis, where in recent years, the development of efficient green chemistry methods for synthesis of metals nanoparticles has become a major focus of researchers. Therefore, our research group also focus on this type of approach, where we use natural sources as a reducing agent. And the main component in order to produce nanoparticles is we have three agents. One is reducing, capping, and also the stabilizing agents. And we want to know what is the role of these three agents here, because we know that the main role of reducing agents is to reduce the compound to ionic particles to form the atoms. And then atoms will develop a particle by combining together. And then the most common and strong reducing agents that use sodium borohydride, amino acids, CTAP, and also hydrazines. And we know that this is a more strong reducing agents that we use. And then other than reducing agents, we also have capping and stabilizing agents in order to stabilize and avoid a further growth and maintain the particles in nano range. And then these both agents, which is the capping and stabilizing agents, is used to prevent uncontrollable growth of particles. And then to prevent the particle from aggregations, control the growth rate and also the particle size, and can allow a particle solubility in various solvents. So why we focus on eco-friendly synthesis method? And of course, green synthesis has gained extensive attention as a reliable, sustainable, and eco-friendly protocol for the synthesizing a wide range of materials or nanomaterials, including metals, metal oxides, nanomaterials, hybrid materials, and also bio-inspired materials. So when we talk about eco-friendly synthesis method, actually is due to the reducing agent that we use. Like before this, many researchers use the hazardous materials of reducing agents. So in our research, we just focus on the green synthesis. That means the green or the eco-friendly, or we can say that the green reducing agent that we use. So why we choose this green synthesis or green reducing agent? It is because, of course, this approach is very eco-friendly and toxic chemicals are not used in our preparation samples, and also can save the energy because external experimental conditions like high energy and pressure are not required, and then can produce large-scale productions of nanoparticles. And then, of course, the biological component itself can act as a reducing and also the capping agent. Therefore, the reductions of the overall cost of synthesis process and preventing them from aggregations for longer of time. So that means we don't need other capping or stabilizing agents. We just use one reducing agent, the green synthesis, the green reducing agents that can act as capping and also as a stabilizing agent. And now we move to the graphene oxide-based metal nanohybrids. So we know that carbon-based nanomaterials have been attracting a significant research interest due to their exclusive characteristic, good biocompatibility, non-toxicity, high mechanical thermal properties, and also relative ease of functionalizations. And we know that among other nanomaterials, graphene has become a rising star in condensed matter physics and also in material research due to its exclusive mechanical, physical, and also chemical features. And we know that graphene oxide have a plate-like structure with a large specific area and also have a fantastic properties. So making the sense to use this kind of materials as a substrate for the depositions of inorganic nanoparticles like silver, gold, copper, palladium, iron, cobalt, and etc. And also the hydrophilicity and exfoliations of graphene oxide have offered exciting opportunities to build nanocomposite or nanohybrid and to form strong physical interactions with small molecules and polymers. And beside that, graphene oxide also has abundant oxygens containing functional groups like epoxy, carbonyl, carboxyls, and hydroxyl, which allow the creations of the perfect surface to anchor the inorganic nanoparticles for the enhancements of wider applications. And therefore, our study or our research, we choose silver nanoparticles as one of the metals materials that can hybrid with the graphene oxide. So among other nanoparticles or among other metal nanoparticles that use, why we choose silver, it is because of course silver is very low cost and then have a high conductivity and then have a large specific surface area, fast electron transfer, and also have attracted much attention due to their potential applications. However, silver nanoparticles have limitations because we know silver is not stable and easy to corrode and also easy to agglomerate. So therefore, when we just hybrid with graphene oxide, so because graphene oxides can anchor or can give support in order to avoid the agglomerations and make it the silver nanoparticles more stable. So that's why, due to the reasons, due to the unique properties of this RGO-AG nanohybrid, and because we know that this RGO nanohybrid have unique properties, and due to this reason, graphene RGO-AG nanohybrid can be used in catalysis and also can be good as a sensors like electrochemical sensors to detect several analytes, and then also can use as a solar cells and good for the photocatalytic activity or photodegradations and also in the energy storage. So actually, our research also focus on electrochemical sensor, but in these sharing sessions, I just focus on the synthesis part in order to produce the GeoAG nanohybrid. And maybe in other sessions, I will share with you about especially in the applications parts. Yeah. So this is the schematic representations for the synthesis of graphene oxide and also metal nanocomposites or metal nanohybrid. So we start with the graphite. So the starting materials is a graphite, and then we produce a graphene oxide by using the simplified Hammers methods. And these graphites will undergo the oxidation process in order to produce the graphite oxide, and then go for the exfoliation process in order to produce the graphene oxide. So after that, like in my case, in our study, we hybrid with AG, and then we just add on with the AG and undergo a process of synthesis process and to produce the metal GO nanocomposite or metal GO nanohybrid. So this is the crucial parts of our study because we try to use green reducing agents like I mentioned before. So in order to produce the silver nanoparticles of these parts, yeah. Also, we also can produce simultaneously RGO, AG nanocomposites. When we have a strong reducing agents or a synthesis time, when we varies a synthesis time of reductions, we also can get the RGO AG nanohybrids. So this is the process, the whole process of how to produce the nanohybrids. Yeah. So this is what is our research novelty. So our research novelty is we want to synthesize or we want to produce GOAG nanohybrid by combining the silver nanoparticles with graphene oxide using diversity of natural sources via green synthesis method. So we have tried with so many natural sources like easy to get in Malaysia, and we just try, and alhamdulillah can give us a good results or good formations of nanoparticles. So this one, yeah. And I just share my previous research findings, and of course this first study is just macam my first baby in how I embark with nanohybrid and also nanocomposites. Yeah, so this is related to the synthesis of silver nanoparticles supported graphene oxide using garlic extract. So in this study, I use garlic extract as a reducing and also as a stabilizing and capping agents with the presence of sunlight as a catalyst. So this is just a very simple reaction method because we just expose the samples in sunlight with sunlight for just 15 minutes. So after 15 minutes, we can form a good formations of GOAG nanocomposites, this one, yeah. And then in this case, the GO sheets might provide an extra stabilization for the growth of AG nanoparticles because of the unique properties of GO. It can anchor and also anchor the particles and then to avoid the agglomerations. And also the interactions between the AG ammonia complex and also the garlic extract makes the breaking of AGN bond, and allyl cysteine present in garlic extract donate oxygen for the formations of Ag2O. So how the garlic extract make it a role, a nice role in this synthesis methods. Yeah. And also in order to confirm the formations of nanoparticles on top of our GO sheet, we use UV visible spectroscopy, and then we just test with several samples. For example, here we just use AG ammonia complex. This is without any GO, just AG ammonia alone. And then we just also test for GO, graphene oxide alone, and then the bare AG nanoparticles. And this is without GO, yeah, only the AG nanoparticles. And then this is our nanohybrid, which is GOAG. So based on this UVV spectra, we can see that the absorption spectrum of GOAG nanocomposite reveal a typical surface plasmon resonant absorption band of AG nanoparticles at 403 nanometer. So this can see a very nice sharp peak of GOAG. So this is a tribute to the AG nanoparticles. So we just can first confirm with UVVs. So this is can confirm that the AG nanoparticles is formed on top of our GO sheets. However, the band at 230 nanometer indicated that GO did not undergo any chemical change. So because we can see this one, right? So in this 230 nanometer peak, just can shows us that the GO is still maintained after 15 minutes of reactions. So that's why we can say that this is can form the GOAG nanocomposites. And also the single SPR band of AG nanoparticles deposited on GO matrix indicated that AG atom were grown as smaller size nanoparticles. So with almost uniform shape rather than bigger size or branch nanostructures. Because we can see this is when we don't put any GO, just the AG nanoparticles itself, we can say that the broader peak. So this broader peak means that pure AG nanoparticle might form as highly polydispersed. That's why maybe it starts to agglomerate like not stable, because when we add GO, we can see the nice sharp peak here. And also we test with in order to study the morphology of the silver nanoparticles, we use the HRTM, and based on this HRTM analysis, we can have the average size of nanoparticle is 90 nanometer. And we just confirm also the crystal plane with our XRD, and we can see a very crystalline of AG, which attributes to 111 HKL site, this one. And then, of course, we also check for Raman spectra in order to confirm that our sample is still have GO characteristics after the synthesis process, so that based on this Raman spectra, confirm that the GO is still maintained, and then we can identify our formation is as GOAG nanohybrids. Yeah? And then for our second study, based on the idea of tolerance reactions of AG nanoparticles, yeah, based on that idea, I modified that synthesis process become modified tolerance reactions. And this is, I'm using glucose as a reducing agent. And then, of course, in this study, the method is also a very simple methods. We just combine together all the GO solutions, AG ammonia complex, and also the glucose as a reducing agents. And then I'm still, the reaction is under stirring for different reaction time. And I just use 2 hours, 6 hours, 10, and also 15 hours. And then we want to see which time or with reaction times that can produce a good nanoparticles. Yeah, so this one. And glucose, actually why we choose glucose? Because of glucose is one of reducing sugar that is capable of acting as a reducing agent, because of it has a free aldehyde group or free ketone group. So that's why, and also glucose is very suitable. That's why we just try glucose, and alhamdulillah also can get a good formations of nanoparticles. Yeah, so this is. So of course, we run for the UV-Vis for the first time in order to confirm the formations, and we can see the difference of color every reactions time, every synthesis time, and this is before the reaction times, and then this is after the reactions time with different hours. And then we can see that the visible color changes in the nanocomposite at different reactions time, which indicate the changes in the aggregation states or size and also the shape of the silver nanoparticles. So first of all, when we have the reactions, in order to confirm that our samples can form the nanoparticles, based on our naked eye, we can see based on the color change. If the color change, the different color change can give us the information that yes, our sample is successfully formed the nanoparticles. However, we still need to confirm by using the TEM, because we want to see what size of that type of nanoparticles. Yeah, and then a large population. So when we did, we also do for the HRTM image, HRTM analysis, because we want to know what is the particles that we have here when undergo 2 hours, 6 hours, 10 hours, and also 15 hours. And then we can see a large populations of well-grown and spherical AG nanoparticles can be seen after a reaction time of 15 hours. And a sharp SPR band also for the AG nanoparticle reflected the formations of almost mono-dispersed spherical nanoparticles with an average size of 16 nanometer. So, so therefore, this 15 hours is very suitable time in order to produce nanoparticles by using glucose as a reducing agent. And then we also do the XRD to make it comparisons between all reaction times. And of course, for the 15 hours, we can see the crystalline of Ag at the HKL side, very sharp peaks and very higher peaks. And also we done for the Raman shift in order to, we want to know, is it the GO is undergo the reductions or not. So based on this Raman study, or the Raman analysis, we can see that for the 15 hours of reaction time, the ID over Ig is equal to 1.06. That means after 15 hours reaction time, the not only the Ag is reduced to Ag nanoparticles, but then they reduce also the GO. So GO become RGO, which is have slightly reductions with the GO. So that's why we can see the peak here, right, in this XRD for the 15-hour sample. So we can see the peak, slightly peak of C in 002 HKL around 23 degree here. So this represent the formations of RGO. So that means during the synthesis process, the GO also undergo the reductions. So make it the RGO, RGO agent nanohybrid for this glucose as a reducing agent. And the last one, I will share with you our study also use a green methods here, but then this one I'm using ascorbic acid as a reducing agent. Actually, ascorbic acid is one of the mild acids lah, yeah, mild reducing agents. However, can also be a good reducing agents with the additional helps lah by the stirring process of this one. So this is take only 6 hours stirring, and then we just use for different concentrations of ascorbic acid. We want to know which concentrations that suitable or give a good formations of Ag nanoparticles. And still, this one is the same method. We just use stirring without any heated. And then why we choose ascorbic acid? It is because ascorbic acid is one organic compound, and we know that the formula which originally called hexuronic acid and dissolve well in water to give mildly acidic solutions. So because based on previous research, normally researchers do research using lemon juice, using orange juice. So that type of oranges too, that one is contain of ascorbic acids. That's why I just try to use this ascorbic acid in our study. So this one. And then based on our UV visibles examinations, we can confirm that with the values of we can see here we have different concentrations of ascorbic acids here. We start with 0.5, 1.0, and also 5.0. So based on this study, we just can confirm that the RGO-Ag with the 5 molar of ascorbic acid can give us a good formations of nanoparticles, of silver nanoparticles. So based on this sharp peak that represent in around 410 something, 410 nanometer something here. So compared to others here, because when we compare to 0.5 and also 1 molar of ascorbic acid, we cannot get the very sharp peak. Because of this one, maybe it is because it's not fully enough to get the nanoparticles. And this result also can attribute or can have the relations with the TEM. When we run for the TEM image, we can see that this one for the 0.5 molar, we cannot see the formations yet because of have a combinations. One, we have a slightly high spherical shapes and slightly much it's like macam agglomerates, right? And then of course for 1 molar, of course we cannot see a very spherical shapes of nanoparticles. So that's why we choose this one is the best one. And then also can attribute with this UV-Vis. So we just can confirm that, okay, so this is based on UV-Vis, and when we undergo for the TEM, it shows a very good distributions of nanoparticles. And this is when with the values of this one 1.5 nanometer, this one. And then same thing, we run for the SRD, so just to confirm. And of course, based on this ascorbic acid, the GO also undergo the reduction process, and we can have the RGO-AG nanohybrid here. So based on this ID over IG, we can have the ratios of 1.03 for this synthesis parts, yeah, so this one. And then I also want to share with you, Alhamdulillah, for my first work with garlic extract just now, because that one is the first work that I embarked with nanohybrid and also nanocomposites. And that study has been published in this Talanta and also have been cited by 100 researchers. And that's mean that green, I mean the garlics, yeah, because garlic is very easy for us to get, yeah, in Malaysia, and we know that, oh, okay, that garlic can be as good as a strong reducing agents. So this is one of my achievements lah based on that garlic extracts. And then also this is my other publications related to nanohybrid and also nanocomposite that I worked before. And during pandemic, of course, we cannot enter lab, and I just focus on writing book chapters. And this is all chapters related to graphene-based nanocomposites, and also the potential applications lah, the applications towards electrochemical sensors and also towards the high conductivities of GOAG nanohybrids, yeah. And then this is my ongoing research. So this is now I just focus on still hybridize the AG nanoparticles and also the graphene nanosheets in order to produce the hybrid ink, and thus take a full advantage of both materials in order to increase the conductivity and also to reduce the concentrations of AG nanoparticles. So this is still ongoing, and hopefully I will get good results in order to increase the conductivity of our nanohybrid or nanocomposites, even though we just use a small amount of AG nanoparticles, because we want to save so much cost lah, yeah. Because we know that when we use graphene is a carbon materials, it's very low cost, and then if we can have we can produce this research, it is much more better lah, this one, yeah. So this is still in ongoing. And then until here, I will acknowledge, I want to acknowledge, of course, my grants, yeah, FRGS and also PRGS, because based on this grant, my research has a smooth sailings lah, yeah. And also this is our research teams in electroactive material RIG, and I will also want to thank to my master students that currently doing research work here. Of course, helping me a lot lah in this research work, and also to my international collaborators. This is my collaborators starting from my PhD journey, which is from India and also from Electrochemical Research Institute. So these collaborators is more on helping me in terms of writings and also in terms of sharing knowledge related to the chemistry parts, yeah. So this one. And then I think that's all. So if you have other questions, or if you want to collaborate with our research group, so don't hesitate to just contact me. So until here, thank you.
Okay, Alhamdulillah.
Yes.
Finish the presentation. Dr. Izrini very orang kata exciting and interesting actually. So I tak sampai hati to stop the
Oh, I'm sorry.
11. So now we are past after 11. Okay, past 12 minutes after 11. So is there any question from the audience? Don't be shy. Kita saja. Please have a question. Unmute your mic or type in the chat box. Okay, if there are no question, I have one common question actually, a simple question. How many times do you try to to synthesize the RGO from the garlic, from the zero until the successful? How many times you try?
Oh, okay. So of course, it's in order to get the good formations, is not only one and or two times. It contributes lots of times lah actually, because we need to try and error, because we use sunlight as a catalyst, because we cannot predict which sunlight, which hours of sunlight that can give us the good formations. So it took some time lah, Dr. Rosna.
Do you ever try to do your synthesis under simulation of apa nama ni, sunlight?
Not. We just use
try.
no, not try yet. But then I just compare with the halogen lamp. But then because I want to just stress about the eco-friendly and also the facade approach, right? That's why I just use sunlight other than use any extra energy throughout my samples.
So maybe next kita
Yes, after this we can just
study
compare.
on the simulation and also under the UV light code.
Yes.
So for the students, don't ever give up. Okay. Tengok Dr. Nuru Isrini many times try and then until successful. So any question from the floor?
All understand. All.
Because semua dah apa nampak lunch
Off.
takut.
Assalamualaikum Dr. Nurul.
Yes.
Saya daripada Pahang ni.
Okay.
Okey, saya nak tanya Dr. Nurul, sebab saya bukan background yang buat nanoparticle.
Okay.
Saya nak tanya, tadi saya tengok slide yang doktor buat analisis tu guna UV kan, UV
Yes.
lagi SRD, HRTM kan. Kenapa
Yes.
doktor tak guna macam FTIR ke memang tak cukup?
Oh bukan, FTIR
Putus ni putus.
of nanoparticles. Actually, I have the result of FTIR, but I didn't include because that one is not the main characterizations. The main characterizations, in order to confirm the formations of nanoparticles, at least we need to have the UVVs. If we have extra, and then the beneficial is the Sharp-10, because UVVs is to confirm the formation based on the spectra that we get, and then we want to just confirm that spectra and what is the particle size and also the particles arrangement. We need to do the HR-10. Is it okay?
Okay.
Dr. Aizan.
Okay, saya chemistry punya ni kan, so tak berapa tak berapa expert lah pasal nanoparticle. Okay, itu saja Dr. Nurul, terima kasih.
Thank you, Taiza. Okay. Any more question? Tak nak tanya ke Dr. Nuru Isrini why she select the garlic as natural reduced agent? So maybe Dr. Nurul boleh cakap why you choose the garlic
Oh,
instead of
actually,
other natural.
okay, why I first choose garlic? Actually, before my research work, PhD work, I work with all Indian researchers from India. So we all know India's they always use some natural sources, right, in order to produce materials. So they choose garlics lah. So that one give me the ideas. The first ideas, okay, just try garlics because garlics we know that have the high antioxidants. So the main properties that we need to clarify is we want to know which materials that have the high antioxidants. So all natural sources that have high antioxidants can be a reducing agent. So first of all, I just try with garlic extract because on a previous research, researchers have done with produce silver nanoparticles alone with garlic extract. But then the limitations is the silver nanoparticles is not stable. So that's why I hybrid scan dia. So I mix with graphene oxide. So that I want to cater the problems in terms of agglomerations and the stability tu. Because GO can act as a stabilizer, can act as an anchor or host materials in order to avoid the agglomerations of silver nanoparticles. And of course lah in Malaysia kan, because of we want to focus on some things yang cheap, very cheap and very easy to find. So that's why I just try with garlic extract. And of course, garlic extract, inside the garlic extract, we have the components called L-cysteine. So that L-cysteine to yang contribute to reducing agent. Because in garlic, we have so many components. So I don't study about the component inside the garlics. I just, based on literature, the L-cysteine is one of the component that contribute to the reducing agent.
Okay, baru ada soalan daripada Dr. Muhammad Naziz. Can we use palm oil instead of garlic?
Okay, Dr. Naziz, I'm not sure because I didn't try yet with oil. But then if that oil is contained of high antioxidants, maybe can act as a reducing agent. But then we can try. However, palm oil is not good soluble, right? Because of oil, kan? Maybe we can try. Maybe we can collaborate and try with a palm oil punya sauce.
Oil kan dia ada problem in term of miscibility kan?
Yes, that was I'm not sure.
So okay, from Dr. Azman, salam. Yes, hadir. Any question from Dr. Azman?
Typing good.
Okay, so I think we comes to the end of our sessions. Okay, so let us kita nak tepuk tangan, tak ada tepuk tangan on the screen ni kan. So let us thank to our two distinguished speaker. Okay, from the ada pun orang tepuk tangan kan, nampak ikut tu. Okay, thank you. So Pak Masnis, Dr. Sofri, and lastly, please fill in the Google form tu, okay, from the our admin, okay, for the apa nama ni, maklum balas after presentation before leave this screen, okay. So we end our session with apa nama ni, tasbih kafarah dan juga walas. Ada satu lagi soalan tu. Hamizah Anis. Okay, Dr. Hamizah Anis. Assalamualaikum Dr. Kartini. Ada plan juga ke untuk buat research berkaitan halal?
Dr. Hamizah. Ada juga, tapi itulah because of saya ada juga try to nak applykan as an antibacterial kan. So maybe bolehlah juga untuk difikirkan untuk ke halal punya ni. Boleh contact lah nanti Dr. Hamizah. Okay.
Most of time our sample is used in bateri yang benda bukan
Yes, it's not halal.
Jadi kita tak terfikir pasal halal. Tapi sebenarnya bahan-bahan pegang-pegang pun patutnya halal juga. Okay. So we end our session with tasbih kafarah dan juga wal asr. Okay, thank you everyone. See you next session pula. Okay. Assalamualaikum.
Assalam. Thank you.